Good morning, everyone. It's Monday, March 16th, and the first day of alternative instruction at home. I'm going to try to make this as normal and regular as possible. And today, in keeping with that, we're going to go over the homework that I assigned last Thursday, and then we're going to finish the document on the notes on speed problems and work problems. Today we'll be doing the work problems, and then afterwards I have a little exercise that's going to build on what we did with decay models for car depreciation, except it's going to be coming up with a model for the spread of COVID-19 in the US in the recorded cases using the data from that website that I went over on Thursday. Okay, so the homework that was due today pertained to speed and work problems, actually just the speed problems. So the first one was the container ship leaving Hawaii at 14 kilometers an hour, and then a cruise ship, heaven help them, left 2 hours later in the opposite direction with speed of 30 miles an hour. How long before they were 248 kilometers per hour apart? So the key to all these problems is to set up this table with two rows, and rate times time is always equal to distance. So the container ship, you fill in the information you know. The container ship went 14 kilometers an hour for X hours, and the cruise ship went 30 kilometers an hour. Because he left 2 hours later, his time or its time would be X minus 2. So then you multiply the rate times the time for each of them to get their distance, which is going to be 14x and 30 times x minus 2. No, I have an extra. There we go. So if they're going in opposite directions, you would add their distances together to get the total distance, which is 248. So this is our equation: 14x plus 30 times x minus 2 equals 248. Then I'm just going to solve that equation for x, and I get x equals 7. So that's the container ship. The number of hours till they are 248, actually the number of hours the cruise ship goes. So if the container ship went x, then the cruise ship must have gone x minus 2, which would be 5 hours. So it'll be 5 hours. The answer to the problem is 5 hours until the cruise ship travels 5 hours until they're 248 kilometers apart. Okay, so then the next problem dealt with an aircraft carrier and a fishing boat. The fishing boat went 20 kilometers an hour for 1 hour. Let's see, the aircraft carrier left 5 hours before, so if the fishing boat went 1 hour, that would mean that the aircraft carrier went 5 hours. We know the fishing boat went 20 miles an hour. The aircraft carrier, that's what we're trying to figure out, its speed. Okay, so this is another opposite direction problem. So looks like I didn't draw my little diagram, but if they start at the same place, that's the fishing boat, that's the aircraft carrier. The total distance is 62, so my rate times time distance, the distance expressions for the aircraft carrier 6x, the fishing boat 20, so I'm going to add those two distances together to get 62 miles. So I get 6x plus 20 equals 62, and then I solve for x, and I get x equals 7. So that's 7 miles an hour, and that's the aircraft carrier. Okay, number 3 was these number 3 and 4 are out and back problems. So with out and back problems, the distances are always going to be the same because it will always be the same distance going and returning. So typically these problems, you have two rows, one for going and one for returning, or outbound and then inbound. You can use either term for it. So we have another cruise ship, heaven help them, and it takes 4 hours going and 10 hours returning. And going, it takes, the speed is 9 kilometers an hour faster than returning. So if you make returning your variable x, then the speed or the rate going would be x plus 9. So then I multiply straight across and I get 4x plus 9 is the distance for the outbound trip, and the inbound trip would be 10 times x, or 10x. So I'm going to set those distances equal to each other to get my equation. I get 4x plus 9 equals 10x, and then I solve that linear equation for x, and I get x equals 6 hours. So that's the speed on returning the inbound trip. So if I add 6 to that, x plus 9, I get 15 kilometers an hour on the outbound trip, which is what you're solving for. And then lastly, the passenger train traveling to New York. Well, this time you know the speeds. Going is 25, returning is 20, and it took 3 hours less going than it did returning. So x would be the time returning, x minus 3 is going to be the time going, 3 hours less. So I multiply straight across to get my distance expressions. 25 times x minus 3 going, 20x returning. So this distances are equal, so I'm going to set 25 times x minus 3 equal to 20x, and that's my equation that I need to solve for x. So I go through the steps of solving that for x, and I get x equals 15. So that's 15 hours returning, and 15 minus 3 is 12, so 12 hours going, and that's what the question asks for. Alright, so those are the speed, rate times time equals distance problem. And now let's look at work problems. So work problems are similar in that you set them up the same way, and that the speed now is how much work they can do per time, their rate of working. So it's always going to be how much work they can get done divided by the time it takes them to do that work. So you do that for each individual, and then together you're going to get your equation by adding up, finding expressions for how much work they can do, and each of them individually, adding that together, their contributions to the total, and setting that equal to the total amount of work that they need to get done. So what that does is, or how that looks like, it looks like this. Okay, the rate of worker 1 times the time of worker 1 plus the rate of worker 2 times the time of worker 2 is going to be equal to the total amount of work that they do. Okay, so you set up a little table just like you do for the time and speed and distance problems. So, and then you set up a row for each worker. So here we have Natalie and Jose, and it's going to be rate times time equals total work. Okay, so working together, Natalie and Jose came up a warehouse in 4.63 hours. Had he done it alone, it would have taken Jose 11 hours. Okay, so the rate that Jose works is going to be one warehouse per 11 hours. So I'm just going to do it WH per hour. One warehouse per 11 hours. And we're asked to figure out what Natalie's rate would be if she's working alone. So I'm going to make that be X. Okay, so the time that it takes them together, well, Natalie would have worked for 4.63 hours and Jose would have worked for 4.63 hours. So the total amount of work that Natalie does in that time period is going to be 4.63x, and the total amount of work that Jose does is going to be 1/11 times 4.63x. So that, if you multiply those together, you get 4.63 divided by 11. So that's the total work Jose does. So now your equation is going to be Natalie's total work plus Jose's total work. And what does that total equal to? It's equal to one warehouse. All right. So that means I have my equation now, and I'm going to solve for x. So I get 4.63 plus, and then let me go to my calculator to see what 4.63 divided by 11 is. So 4.63 divided by 11 is equal to 0.421. I'm going to round to the nearest thousandth. Alright, now I'm going to subtract out 0.421 from both sides. And I get 1 minus 0.421, 0.579. By the way, oh, I forgot the x. So 4.63x equals 0.579. And now I'm going to divide by 4.63. So I get x equals 0.579 divided by 4.63. So that's 0.125. Okay, so and what is that? That's Natalie's rate. So she's doing 0.125 warehouses per hour. Okay, so the question is, how long would it take Natalie to do it alone? So she has a rate of 0.125 hours. So let's say her equation then would be 0.125 warehouses per hour times how many hours it takes her to do one warehouse is equal to one warehouse. So her rate times time would be equal to one warehouse. So that would be the total work. So now I just need to solve for x. So I'm going to divide both sides by 0.125. And let's see, what do I get? I get 1 divided by 0.125. So 1 divided by 0.125. So it would take her 8 hours, and that's my answer. So notice I had a separate, once I figured out what her rate was, Then I needed to write another little equation of rate times time equals total work performed to figure out how long it takes her to do one warehouse. So once you get her rate, it's her rate 0.125 times however long it's going to take her, which is what you're solving for, equals one warehouse total. Solve that, you get 8 hours for Natalie to do one warehouse by herself. Must be a pretty small warehouse if she can do that in 8 hours all by herself. Alrighty, let's look and see what other problem we have here. So we have Michaela cleaning the attic in 15 hours. Mary can do it in 16 hours. How long will it take them if they work together? Alright, so I'm going to set up my chart again with 2 rows, one for each of the workers. So we have Michaela, and we have, let's see, who's the other one? Mary. So it's rate times time equals work done. Okay, so Mary can do it in 15 hours, so her rate would be 1 attic per 15 hours, or 1/15. Mary can do 1 attic per 16 hours, and so that means how long would it take them if they work together? Well, if they work together, they will both work the same amount of time, which is what we're trying to solve for. So we would get 1/15 x, and here we would get 1/16 x for their total work. So together, so the work that Michaela does plus the work that Mary does has to equal 1. So that would be 1/15 x plus 1/16 x is equal to 1. So now I have a linear equation that has fractions. So I'm going to get rid of the fractions by multiplying by the least common multiple of 15 and 16. So that's the smallest number both of them go into. So let's see, I can easily find a common multiple by just multiplying them together. And I really don't need to use, it would be great if it's the least common multiple, that would keep my numbers down. But in the interest of speed here, we're going to just multiply by the least common multiple, which is 300. So I get, when I multiply both sides by 300, I get 300 over 15x plus 300 over 16x equals 300. So now, what does that give me? That gives me 300 divided by 15 is 16x plus 15x equals 300, and then I'm going to add them together. I get 31x equals 300, and then 300x equals 300 divided by 31. So let me go to the calculator. I do 300 divided by 31. That's equal to 9.67 hours. So how long would it take them to do that together? It would be 9.67 hours. And since 0.67 hours is 2/3 of an hour, which is 40 minutes, the answer would be really 9 hours and 40 minutes. All right, so that's a very exact answer. Or you might write that as 9:40. Okay, so let's see. Working together, Adam. So the next problem here is basically the same one, except with different names and different numbers. But just for emphasis, we'll do it again. So rate times time equals work. Well, actually, I'm sorry. This is like the first one we did, not the second one. Okay, so you have Adam and you have Ashley. So Adam, they mopped together in 4.4 hours. Had she done it alone, it would have taken Ashley 8 hours. So Ashley, working by herself, her rate is 1 warehouse per 8 hours. All right, and if they work together, their time is going to be 4.4 hours. Each of them will work for 4.4 hours. And Adam is what you're solving for, what his rate is. And once you know his rate, then you can figure out how long it would take him to do it by himself. So this problem is exactly like the first one we did. Okay, so his work in the 4.44 hours is going to be x times 4.44. And then Ashley's is going to be 4.44 divided by 8. Because that's what 1/8 times 4.44 is. Multiply this times that to get, and here you multiply that times that to get that, and then that times that to get that. Okay, so total they do 1 warehouse. Okay, so Adam's contribution plus the amount of work Ashley does, her contribution is equal to 1 altogether. So I get 4.44x plus, and then let me go to the calculator. Oops, wrong one. 4.44 divided by 8. That gives me 0.555. And I get 4.44x equals, I believe I'm going to get, if I subtract 0.555 from both sides, I'm going to get 0.445. Well, I better do it on my calculator just in case. Yes, I was right. Divided by 4.44. Oops. And that gives me okay, so I'm going to round, so that means Adam, I believe, is doing 0.1, and it was 1002 2 warehouses per hour. Okay, so how long would it take him to do it alone? So his rate is that. So if I make x now, if I make, well, I'll use a different variable. I'll use y equals time for Adam to do it alone. So his rate times his time equals 1 warehouse. So I'm going to now divide by 0.10022. You can tell one of my sons just got up and is running down and wondering why I'm sitting here with a headset on. So that's going to give me that is going to give me, I need to do 1 divided by 0.10022. That's really 1 divided by 0.1, which is going to give me 10. So it would take Adam 10 hours.